Hi everyone, in this video we're going to go through 1E, composite functions. So during Head Start you may have had slightly different notation that I haven't updated in this document. So I'm going to go through, and I know that we did cover composite functions, but I'm going to go over it again because I'm not sure whether we actually did every question. All right, so this sort of notation we call f of g, but it's not really something that you're going to see on your exam or on your SACs. It's just seen in your textbook, so just putting it there so you're aware it's in your textbooks, but it does mean the same as f of g. So we're just substituting a function within a function, and that's the same as what I've got written here. And I might just stop there. And you can define it as a new function if you want. So h of x is the composite function of f and g. All right, so f of g of x, that just means that we're substituting in a function into another function. So we may be familiar with f of 2, so that means we're substituting in 2 into the function, but f of g of x means that we're substituting g of x into our function. Now your domain of your composite function, so f of g, is the same as the domain of g. So whatever is inside your bracket, so in this one it's g of x, that's the same as, so the domain of g of x is the same as your composite function. It is only defined, okay, so if we're doing f of g of x is only defined, so defined meaning that we can do it, if the range of g is a subset of the domain of f. So that means we do have to identify the domain and range of each function and then look at the range of, in this case, g, so the function that we're substituting in, and see whether it's a subset of the domain of f. Okay, so we're going to do a few practice questions very soon. Now, you can have the opposite as well. So all we're doing in this second part is g of f. So we're substituting f of x into our function g. Okay, so you can see that's here. And you can call that a new function if you like. You can call it h of x. Now, this sort of notation, there's nothing wrong with defining something as a new function. So instead of writing g of f of x, if you wanted to, you can say, well, I'm going to let that equal h of x. You can let it equal m of x. It doesn't matter what letter you use. So we tend to use f, g, h to define functions, but there's no set rule. The variable x might also change as well. So you might have t, you might have n, but x being the most common. So the two types there that you're going to see are function f and function g, and either substituting in g of x into f or f of x into g. Okay, so, and lastly, in general, f of g of x is not equal to g of f of x. Okay, so basically substituting, not substituting in the same function. You're going to have two different functions, so they're probably not going to be equal to each other. It's important to remember what we've got here with the domain and range, because on an exam, or even on the SAC, but probably more likely on an exam, you're going to see composite functions, and you also need to know what the domain and the range is of your composite function, or whether a composite function can be defined. So make sure that this is in your notes and that you're aware of it. So it's not something that you need to learn off by heart, probably not for now anyway, but maybe closer to your exams, understanding how to get the domain and range. All right, I'm going to skip this example because I don't have one there, but let's do some practice questions together. Okay, so for the functions h, so remember we've always got the domain first. So this, the domain is any real value excluding 0. And here's our function here of h of x. Now you can see it does exclude 0 because if we were to substitute x equals 0, we've got 1 over 0, which is undefined. So it's given us the domain, but if you were to work out the implied domain, you could get the same thing. And then our second function, g, so our domain is R positive, so any positive real number. So remember, that doesn't include 0, and it's 3x plus 2. So obviously, 3x plus 2 would be any real number, okay, but it has defined the domain as only being the real positive values. And that might help us when we're doing defining our function, okay? So remember that in order for a composite function to exist, you do need to look at the range of the function that you're substituting in and whether it's a subset of the domain of the original function. All right, let's have a look at doing this. So let's find h of g of x. So that means we're taking the function h. So there's h of x equals 1 over x squared. And wherever we see x, we're going to substitute in the function g of x. All right, so instead of writing 1 over x squared, we're going to write 1 over, and function g is 3x plus 2. So I'm going to write 3x plus 2 on my denominator, and remember that's all squared. So I'm just going to write it, leave it like that. Oh, so sorry about that. I just breathed in the wrong way and swallowed a whole chunk of air. Okay, I'm sorry about that. That would have been quite a shock. All right, now you can leave your answer just like that. We do not need to expand the bracket 3x plus 2 squared. So if this was an exam question, often you would see it as one of the first ones. And time again, you see in examiners' reports that you don't need to expand those brackets. So just leave it like that. Okay, it's probably worth 1 mark. All right, we do need to state the rule and the domain. So let's look at the domain first. So remember our notes, if we go up here. So this notation, we're using f and g, but the function that we're substituting in the question that we're doing is g of x. So we can kind of just imagine it's similar to this, but instead of f, we've got h. So the domain of our composite function, f of g of x, or in this case it's h of g of x, is the domain of g. So we're going to go back. Okay, so the domain of g of x, the domain of g of x is equal to the domain of hg of x. All right, so the domain of g of x is R positive. So the domain, didn't really write this very well. So the domain of h of g of x is equal to R positive, any positive real number. All right, so now we're going to do it the other way around. So we're going to take g of x, which is 3x plus 2, and we're going to substitute in h of x. So we're going to have 3, h of x is 1 on x squared plus 2. All right, and we do need to expand that. We shouldn't leave it like that. So it's going to be 3 on x squared plus 2. All right, so there's our rule. Now our domain, so for this one, the domain of g of h of x, that bracket, h of x is equal to the domain of whatever is in the middle, so h of x. And the domain of h of x is any real value excluding 0. Okay, moving on to question C. So this time, I won't go that far, similar to question A. All right, so we know that h of g of x is equal to 1 on 3x plus 2 squared. So now all we're doing is substituting in x equals 1. Okay, so we can see 1 there, so we're substituting for x equals 1. So we've got hg of 1. So we're going to have 1 over 3 times 1 plus 2 squared. So we've got 1 over 3 times 1 is 3 plus 2 is 5, and 5 squared is 25. So 1 over 25. right, let's do, write down g of h of x, and then we'll substitute in 1. So we had 3x squared plus 2, and then we're substituting in 1. So 3 on 1 squared plus 2. 3 on 1 is 3 plus 2 is 5. Okay, question 2. The functions, actually I think we did this question in class. I think we skipped number 1. So that's good. Let's do question 2 again anyway. The functions f and g are defined by, so we've got function f, so the domain is R, and our function is x squared minus 2. And then function g, our domain is from 0 to infinity, and we're including 0. And we've got square root of x. Now, the question says, explain why g of f of x does not exist. So it's told us it doesn't exist. So if you've got a question like this on an exam, you need to show why it doesn't exist. And if you're sitting there thinking, oh, but it does exist, don't go thinking that the question's wrong. Okay, you're wrong. So just it's not a trick question. It's not for you to say, oh, it does exist. Okay, so we definitely know it doesn't exist. Now, if you ever get a question like this for the composite function, you should know straight away we're looking at the range and the domain. So basically, for it to exist, for a composite function to exist, composite function to exist. All right, so let's go back to our notes because it's up the top. All right, so the function we're doing is similar to this. Well, it is g of f of x. So for it to be defined, the range of f is a subset of the domain of g. Okay, so we've got to work out the range of f and then see if it's a subset of the domain of g. Where am I? Too far. Okay, so the range of f of x has to be a subset of the domain of g of x. All right, so the range of f of x. So f of x is x squared minus 2. We just need to also think about the domain. Now, if there's any restriction on the domain, which there isn't, it's any real value. So our range, if you think about this, is a parabola that's shifted down 2. So it's going to go from -2, including -2, to infinity. Now, I'm going to just put the subset sign in there, but we know that it's not going to be a subset, so we'll cross it out in a sec. The domain of g of x is 0 to infinity. So -2 to infinity is not a subset of 0 to infinity. So what you've got written here is fine. All right, for a composite function to exist, the range of f of x has to be a subset of the domain of g of x. In this case, -2 to infinity is not a subset of 0 to infinity. Therefore, g of f of x does not exist. Now, if you think about, if you want to look at it on a number line, so you don't have to always do this, but sometimes visually it's good to do a number line. Okay, so we're going from, all right, so our range is going from -2 to infinity. And then our range is going from 0 to infinity. So basically, if it was a subset, this bottom line, which represents our range of f of x, would be a part of the domain of g of x, which it isn't, okay? So that it doesn't exist. All right, so for question B, we're going to do, oops, I just want to scroll down. We're going to find f of g of x and then sketch its graph. Might just do that so we can actually see what the function is. All right, so f of x is equal to x squared minus 2, and f of g of x So g of x is the square root of x, and we're going to square that. So remember, we're just substituting it into the function here. So the square and the square root cancel each other out, and we're left with x minus 2. Now, we've got to look at the domain before we sketch it. So remember, the domain of f of g of x is the same as the domain of g of x. So the domain of g of x is 0 to infinity. All right, so when we're sketching, got a y-intercept of -2 and, whoops, and an x-intercept of 2. And we are starting at 0, so we can draw a closed circle. And it goes up like that. We should call that x. This is f of g of x. And I think that's all we have to do. All right, let's move on. So question number 3. So we've got S. So S is not representing, it's not any part of the set notation. So we're going to have to find what S is. So S just represents the domain. Oh, it says real here. S is the set of all real values of x. So S is representing our domain. So we've got to work that out in question A. And then we've got f of x is equal to the square root of 4 minus x squared. And then we've got g, so our domain is any real value, and then we've got the function for g of x. All right, so find S. So for S, it's the implied domain. So we've got the square root of 4 minus x squared. So we do know that we can't take the square root of a negative number and get a real value. So let's have a look, think about what our numbers can be. Now, if I were to substitute in any negative number, so let's say I substitute in -10. So -10 squared is 100. 4 minus 100, I'm going to get a negative number. If that was a plus in there, so it was 4 plus x squared, we would actually be able to do any real value. But because it's a minus, we got to think, well, this x squared has to be, so 4 minus x squared has to be greater than or equal to 0. So oh, what am I doing? It's meant to write -4. Don't forget to switch your inequality sign. All right, but because we're squaring that, the square root of 4 gives us a positive and a negative value. So we're going to have to have x has to be greater than or equal to 2. Sorry, -2. So when we substitute in -2, we're going to have -2 squared. If I substitute something in smaller than -2, so it's always a good idea to check. So if you're unsure about your inequality sign, just check. So -2 squared is 4, so 4 minus 4 is 0. If I was to substitute in -3, I would have 4 minus 9, so I'm going to have a negative. So x has to be greater than -2, or x has to be less than or equal to 2. And you could just write that as -2 to 2, like so. All right, so S equals, all right, I haven't left myself much space to do B and C. So B, find the range of F and the range of G. So let's do the range of F first. Okay, so your domain for F is -2 to 2. Now, when we substitute our values in, when I substitute in -2, I'm going to have y equals 0. When I substitute in 2, I'm going to have y equals 0. So if we look at the graphs, I was just graphing it, you can see it here. You might not have you won't have a calculator in your exam 1. So it's important to understand, well, what is actually happening with our graph? So your maximum, and when we do calculus, we can look at maximums. But this graph here is, well, what happens when you could do a table of values if you want, but your highest value is going to be the square root of 4 when x equals 0. So the square root of 4 is 2. So your range is going to go, so remember when we substitute in -2 or 2, we get y equals 0. And then it can go as high as 2, and they're included, so we use square brackets. So you can see that also on our calculator. It's a little bit hard to see. I can just zoom in maybe a little bit. Okay, so you can see the graph there. All right, and then part C, state whether or not f of g of x and g of f of x are defined for each and give a reason for each. So we can just set up a little table. And then we're going to do the domain and the range. All right, so the domain of f of x was -2 to 2. And the range was 0 to 2. And the domain for g is r. And the range, so we've got a parabola that's been shifted up 1. So it's going to go from 1 to infinity. All right, so let's do f of g of x first. Test whether it's defined. So we want, I always get them mixed up. So let's go back, f of g of x. F of g of x. So the range of g is a subset of f. All right, so the range of g, so the range of g is 1 to infinity. And the domain of f is -2 to 2. All right, and we can just put the subset sign in the middle. Now, is it a subset? No. Okay, so we're going from 1 to infinity. Here we're going just from -2 to 2. So it's not a subset, so it's not defined. All right, and then let's do g of f of x. All right, so our range of f of x is 0 to 2. And then our domain of g of x is r. Now, is that a subset? Yes, it is. Okay, so it's defined. So we can do g of f of x, but we can't do f of g of x. And it won't always be the case where you can do one and not the other. I mean, both of them can exist. You can also change the domain to make it. So if a question said, well, change the domain so that the composite function exists, then you need to consider the domain and range when you're doing that. All right, I'm just going to see how much more we've got. Okay, one more question. All right, question 4. Let a be a positive number. Let f, okay, so I'm going to write this down. F of x equals a minus x, and then g of x equals x squared plus a. Find all values of a for which both f of g of x and g of f of x exist. Okay, so here is a question where we've actually got set domains. All right, so let's set up a little table like we did with the previous question. I'll do the domain here, and then the range. All right, so our domain of f is 2 to infinity. And our domain of g is -infinity to 1. All right, so let's have a look at f of x first. So it's a linear graph. it has a y-intercept at A. Okay, so if I was to graph this, it's a good idea to graph when you're working out your domain and range. So it's got a y-intercept at A. Now, does it say A is a positive number? Okay, so that's very important because then I know that it goes through A there. And that means your x-intercept is going to be A as well. And your domain is going from 2 to infinity. Now, we don't know the value of A, but that's okay because we're just going to be substituting x equals 2. So f of 2 is equal to A minus 2. So that means that f of 2, wherever I'm to put it, is going to, the corresponding y coordinate is A minus 2. So it's going to be 2 A minus 2. Okay, because it's just in terms of A because we don't know what A is equal to. So that means we're going to start, actually it doesn't really make any difference. So our range is going to go at A minus 2. I don't need to put it on my graph. And oh, actually, sorry about that. Probably should put it on. Okay, so there it is, point there. And your graph, because it's a negative gradient, is going to go down like that. So the reason I erased that range is because we're going from negative infinity. So remember, these are your y values. We always write the lower one first because it's heading towards negative infinity. The lowest value is going to be negative infinity and the highest value is going to be A minus 2. And that's included. All right, so let's do g of x now. All right, so here's A. So remember, A has to be positive. Actually, I probably shouldn't have done that because our domain, let's get rid of that first, is going from negative infinity to 1. So let's work out what f of 1 is. Not f of 1, sorry, g of 1. So 1 squared plus A, so it's going to be A plus 1. All right, so when x equals 1, we're going to be at A plus 1, so we're going to be up here. Now that's what your graph is going to look like. Now when we think about the restriction on our y values though, the lowest y value is A. This is a tricky question. And then because your domain is going from negative infinity to 1, your y values keep going up until infinity. Like so. Okay, so even though it ends there at x equals 1, on the left-hand side, it does go up to x equals negative infinity and up to y equals infinity. All right, so we want them to exist. Okay, let me just scroll down. So let's do f of g of x first. All right, so the range, oh, probably shouldn't put equals there. The range of g of x is A to infinity. And the domain of f is 2, square brackets, 2 to infinity. And so that means A has to be 2 or more. Okay, so for this case, A has to be greater than or equal to 2 for this to be a subset. Okay, so A to infinity, if A was 2, it would be a subset. If A was 3, it would be a subset. But if A was 1, it wouldn't be a subset because we're below 2. All right, then g of f of x. So the range of f of x is negative, oh, I did square brackets there, that should be curved brackets. Always have curved brackets for infinity. So negative infinity, a minus 2. And then the domain of g is negative infinity to 1. All right, so we're going from negative infinity, so we're only looking at the a minus 2 and the 1. So a minus 2 has, for it to be a subset, has to be less than or equal to 1. So a has, so bring that 2 over, so a has to be less than or equal to 3. So a has to be greater than or equal to 2 or less than or equal to 3. So if we're writing that just as 1, a is greater than or equal to 2 or less than or equal to 3. All right, so quite a tricky question, although I like that one. It's good. All right, I'll leave the video there and then I'll do another one for the next section.